And now we can go ahead and dive in. So again, this is going to be modernizing apps with Microsoft Azure. And I'm Brian, and we have Haley with us as well. So first of all, let me just introduce myself. This is me, I'm Brian. I do have an MCT, and I have 9 Azure certifications, which is something that it behooves me to have multiple certifications because of the fact that I am an MCT and then I can train on more of them. But ultimately, at the end of the day, I just love working and talking about Azure and training people on Azure. And so I've been a developer for about 20 years as well, and so quite a bit of experience. So if you ever want to talk about certifications or just anything developer shop wise in the .NET framework, I'm happy to connect at BL Gorman on Twitter or LinkedIn, Brian O. Gorman, and I would love to connect with you and network, talk shop, whatever you need to do. The other thing is just I was awarded Microsoft MVP this year, which is my first year, and I'm so excited for that. And just really cool things like this where I get to share information with the community, help to keep that going. And the last thing there is I did have a book out called Practical Entity Framework. That is actually, I'm going to be the first author right now to say, don't buy my book. And the reason I'm saying that is strictly because there's a new one coming out next month, and literally within a few weeks there will be a second version for .NET 6 and EF Core 6. And so I'm pretty excited about the second edition, and so I say don't buy this book right now, just wait a couple weeks and you'll get the latest edition. All right, I'm gonna turn it over to Haley, let her introduce herself.
Thanks, Brian. I'm Haley Hanreddy. I'm a strategic account executive here with Opsgility, and our team is here to help support you with any of your skilling needs in terms of your transition to the cloud. So we not only provide training, but we also are a cloud service provider. Within our consulting team, we also have a variety of team members available who can give you some direction. And then if you need us to implement that for you and then train you how to use it or assist your team with implementing it themselves. We also are able to help your company with virtual events. So for example, we have our virtual conference manager, which is a platform that is built off of Microsoft Teams, and it allows you to engage your audience virtually, safely, conveniently, internationally. We can do events as as small as 300 to 20,000 if that's what you need. And so with all of these different services combined, we partner with organizations across the globe to help with their digital transformation journey. And so we're looking forward to this webinar today and showing you another example of how we can do that. Back to you, Ryan.
Awesome, thanks, Haley. All right, so today what we're going to do is we're really going to just talk about what it means to modernize and move to the cloud. And we're going to take a step way back, and we're going to start with traditional architectures, which I know some of us are still using. And so this is going to be a really great chance to kind of talk about the journey from where you are or where you were to where you are now, and potentially where we can go in the future. And so we'll start with looking at environments and processes, and we'll talk about a couple of the critical frameworks that Microsoft has created for us to follow to make sure that we don't fall into pitfalls or have some problems along the way. So the first one's the cloud adoption framework, and the second one is the well-architected framework. And then we'll move from those into, well, what does it mean to really have a cloud application? What are some of the characteristics of that? And we'll dive into a couple of the specific implementations that kind of get the buzzwords going, microservices and serverless. And we'll wrap up with just a brief overview of automation and where we want to go with that as well. So we'll dive in here just talking about traditional architectures. And ultimately, where we were, we had these traditional data centers, and there we had a company that potentially had to be responsible for everything that they were doing, every piece of the puzzle. And that meant the entire data center. And we'll just kind of home in on that in a minute. But for a developer or an application person or team, we were really in control of everything, which meant we also were responsible for everything. We had all the tools, all the settings, all the application environments, configuration. We were literally going out to machines and installing IIS or potentially Tomcat if you're in the Java world. Whatever world you're in, you were still responsible for all that configuration. And then you had to make sure that your code worked, and you had these centralized repositories, whether it was Subversion or Team Foundation or the VSS 6 days, if anybody's been around as long as I have to remember when those got corrupted. It was never any fun because you were done. But we moved into Git now, and we'll talk about that as we go. Now, there were usually, or still are, 1 or 2 people on these teams that know everything, and then they kind of just expect everybody else to also know everything, even though it's not well documented. And so you end up with these scenarios where you have these manual and obtuse deployment processes that only a few people really understand. So you're pushing buttons or just kind of pushing and praying even locally and hoping things work. And then when it came to actually getting things built, we're talking weeks to months to years for these development life cycles and the traditional waterfall pattern where we were first we go do the requirements, and then we go and we talk about what we're going to actually implement, and then we code it, and then we, in the waterfall pattern, and we ended up never getting to a real good product. So we started moving into the agile. We'll talk about that a little bit today, but not too much. In the end, if something broke, someone had to fix it. Now that meant dropping whatever you were doing and troubleshooting and getting it working. We ended up with developers building out these greatly cohesive monolithic applications that had monolithic databases, and the level of entry, the barrier was just very high for a new developer coming onto the team. It led to a lot of fear. And so ultimately, that's not just a new developer in the, you just got out of college and you're trying to become a developer. You don't know what you're doing, but even the developers who transition teams. So if I have a giant organization and I'm a developer and I'm having a great time and I love my job, I might feel like I'm going to get a promotion, go to another team, and all of a sudden it's like getting, running into a brick wall. The team does something completely different. So a lot of process, drift as well with that. And so with the cloud journey, we're going to try to move away from some of that. And when it came to the data center, in general, we are again responsible for everything. And typically the developers didn't have to do a lot of this, where the developers would actually just rely on another team. And this is another team who also had similar issues with 2 or 3 people who kind of understand everything, not a lot of documentation, but ultimately responsible for everything. If a hardware failure happens, who's fixing that? Somebody has to come into work or maybe even drive a couple hundred miles to go quickly get a replacement part, whatever it might have been, to get your system back up and running. But in addition to hardware, you were also responsible for all the configuration of your network. You had to do the actual physical wiring in your building, make sure that computers were connected, make sure that the identity was set correctly on those, make sure that the NIC cards that were connected to your servers were working correctly in your whatever load balancing scenario you had, or network address translation or firewalls. All of that was someone's responsibility to literally be in the room. But that room also had to be monitored. You had to have people who were locked out of that room, and you had to have a specific list of people who could get in, and that had to be some kind of security system. And then you needed people to make sure that that was enforced, that the right people were getting into the room. And so there's just all these layers of things that were going on in our traditional data center. Additionally to that, we were talking about getting licensing for all of the different tools that our teams are using, the compliance issues that we might have had about storing data and making sure that it was always secure. A lot harder when that's on our premises because now we're responsible for it. And things like running manual backups. We've all heard the horror stories about taking the tape drive across, to a different place, and it gets lost or corrupted somehow. And the final piece of the puzzle, which no developers like, and I'm sure no admin people like either, is these support hours. So you get long hours of making sure that you have to be available, and the arguments of who's going to work over the holidays. Every year it's always the new person, right? Because they have the lowest seniority. So you get these scenarios where you're responsible for everything. You have all these problems that you have to handle as they happen, and ultimately you're taking care of yourselves. And then you create this culture of just a few people kind of know what's going on, and the rest of the people are maybe getting there, but it's always kind of this, oh, we have a lot to go through. So the idea now is we want to move to the cloud, and we want to try to avoid some of that. In addition to that, the real meat of this is to get our application lifecycle to a point where we can move as quickly as possible. So we're going to talk about replacing things like our waterfall-ish development, where we had this culture of slow change. This is how we've always done it. and even extra hours that were spent building tools that actually were just purposeful to help keep things working on our environment. So we had to, not only do we have to develop these applications with features, we had to actually develop special tools to make sure we could do what we needed to do in our environment. And this strange custom things also lead to all kinds of issues and things like configuration drift coming into play. So now we've got all these different servers, all these different things that have been out there for 15 years or whatever it was, 5 years. No server lives 15 years, right? But ultimately, 5 years down the road, you've got this configuration drift and people are coming in and saying, well, what is this for? And nobody knows, but nobody's confident that you can actually delete it. Because what happens if you do? Nobody knows what the repercussions might be. So you just leave these things, and suddenly you've got these really weird and possibly very insecure scenarios happening. And so you also get invalid test and QA environments. And what I mean by that is we don't have the same environment in production and in test. We just use a different kind of machine just because it's the cheaper version and we don't have to keep it running all the time or whatever, but it doesn't necessarily mimic exactly what test and QA, those don't necessarily mimic what production are going to be. Yeah, and so again, we're talking about having long hours of support. We're talking about having lots of stuff happening on manual weekend deployments. But the other thing is, I wanted to include in this is the little to no security concerns. Now, I think most people would argue with me and say, no, we're definitely concerned about security. And I would say, really, is that true? Because I've been a developer for about 20 years. And out of that time, I don't remember any of those years when SQL injection was not on the top 10 OAuth security risk. Now, if that was truly something we were concerned about, would that have stayed there for 20 years? I know we've taken efforts, but it's still there, which means we're not as concerned as we should be. Okay, maybe I'm a little jaded. I've been a developer for a long time. I've seen a lot of this, but even if I'm a little jaded and just kind of maybe embellishing this a little bit, I'd be willing to bet a lot of money that some of this struck a nerve with you today, right? Yeah, I think so. Okay, so what do we do? How do we move forward? Well, along came the cloud, and this came along a while ago, and we thought, okay, here comes Mighty Mouse to save the day. We've got everything we need. It's the cloud, and the problem was it didn't solve everything, at least not right away. And not only that, but it was very confusing and tricky. Now, part of that was definitely on the cloud itself. There was some barrier to entry. There was some cost concerns. There was actual additional tools you needed to install. As a .NET developer, I had to put extra tools on my machine in order to be able to write code for Azure. It was weird. And not only that, I had to pay for it just to test things. I was struggling to want to learn something that I had to pay just to learn. And so Microsoft said, okay, enough of that. And they've taken care of those barriers of entry for sure. But there was also some personal barriers, some barriers within teams. And this is still an issue and something to consider now today even. You have people on your team who might say, I'll never put my data in the cloud because they're just so concerned that someone might get access to it. But I'm here to tell you that you're likely more insecure now putting your data on your own servers in your own place than you would ever be at a place like Microsoft. Now that might not be true, but that's my personal belief. So yeah. The other thing is there were people, or there still are people that say, well, I can't trust whatever, enter your big name company here like Microsoft, Amazon, or Google would do with that data in the long run. Maybe they're actually using it to mine my data to figure out patterns so they can sell more things or whatever those concerns might be. My argument against that would also be, I think that's a little excessive. I doubt they have the time or the concern to really go in and dig in your data to find those kinds of things. They've got plenty of their own. So anyway, along the way, Microsoft said, let's make this better for people. And so we have this plan called the Cloud Adoption Framework. So we're going to talk about how this is going to be a great way to move from your traditional web to another application or different cloud-based approach. So with this, it's often overwhelming to know where you're going to start on your cloud adoption journey. So for this reason, Microsoft has actually created a number of tools for you. And they also have a very vast network of internal resources at Microsoft with cloud solution architects. But not only that, they have partners like Opsgility. Now, with Opsgility as a Microsoft partner, you know that you can trust them to help you expedite your cloud journey. You can have that adoption journey implemented by people who do this all the time, and do work in hand in tandem with Microsoft to ensure that you're getting the best possible overall experience. So from thousands of documents on architecture, best practices and tutorials, to professional resources, additional training credits so that you can get trained up on and get your skill gaps filled, tools to calculate your overall costs, your workload needs, all of this is available through Microsoft. This gives you an exceptional and well carved out path, so you don't have to trailblaze on your own. It's been proven time and time again for successful migrations.
So, Brian, I think we have a question here.
Sure.
So what is the difference between cloud adoption framework and a well-architected framework?
Oh, great. Excellent question. So we will talk about the well-architected framework in just a minute. As we talk more about the cloud adoption framework here, what we're going to look at is the overall journey. So we have an organization, and what are we doing to move to the cloud in general? So it's kind of like getting in the car, and we want to go from point A to point B. We don't really care, exactly what the car is. We just want to get to where we want to go, and we want to make sure it's safe. And so driving in that car, that's kind of like the cloud adoption framework. Getting from point A to point B, we'll take specific roads. We have a map that gets us there as quickly as possible with the best fuel efficiency that we can offer. That kind of thing is the cloud adoption framework. When we talk about the well-architected framework in just a moment, what we'll be looking at there is one specific implementation or one workload. And so now, instead of the entire organization just trying to get these plans in place, we're looking at, what does it mean if I want to just move my major line of business app? Then you would take that central approach around that single app and build that out with a really great architecture. Now that might be infrastructure as a service or software as a service. So hopefully that answers the question, but that's a really great question, because it can get really confusing when we have multiple frameworks. Which one are we using? What are we doing it for? So yeah, keep those coming. All right. So another thing to consider in the cloud adoption framework is why you might be migrating. And so there are a number of reasons. And just to kind of summarize a couple of them, maybe it's something like, well, somebody told me I had to, or we're going to retire the data center. We're actually tired of supporting the hardware. We've decided at this point it's not worth our time, effort, and money, and it's actually going to do us a great favor to move to the cloud. Or it might be that you bought another company. Maybe you've acquired somebody and they have a data center, or you have a data center and the other team is in the cloud. And now you have to figure out, well, how do we make this hybrid connection between their systems and ours? And maybe something happened that's changed with support on a product that you use, or perhaps someone's major application they used to send to you that you shipped and put on your hardware in your local data center is now only available in the cloud. And so you no longer need the hardware, because you're just using their cloud-based adoption of their stuff, and you no longer bring their box product into your data center anymore. So all of that could be in play. Additional things would be with all the remote changes we've seen as we've moved through COVID these last year and a half, and seemingly at least another half or 2 years. Who knows how long this is going to go on, and maybe this will be our culture from now on. Maybe we stop using actual hardware for our desktops and we start virtualizing that. And that's available in the cloud now, that we could actually have really great quick scenarios to start using that. Or it could just be IoT. IoT all the things, just like containerize all the things in the image here. You might be using telemetry coming in, and you need some place to store all that data, and you need something to process it. And those are really great tools that are available in the cloud. So with all this, you can count on Microsoft to give you the proven tools. You can follow the patterns that they have available, so you don't fall into some pitfalls. A couple of great patterns are, again, a dictated architecture is an anti-pattern. We don't want to actually have someone saying it has to be like this, like we must containerize all the things, because maybe you shouldn't. And the idea is make sure that you are prepared to answer for why you're saying that. But instead of giving this dictated architecture, let's take some time. Let's look at what we have. Let's take a migration assessment and let's figure out what our plan should be to move forward. And then considering other things like security, governance, and compliance, where you can actually use baked-in scenarios at Azure with the tools to actually make sure you're not in violation of them, you could really move quickly. And so having all this with the Cloud Adoption Framework gives us a great plan. So you'll go about developing this. Again, the first thing you want to do is kind of just take an inventory. And what I mean by this is, what do you currently have? Do you currently have a number of database servers? Do you currently have a number of web servers, networks, translations, whatever you're doing? Let's find out what we have on-prem and then talk about what that's going to look like in the cloud. But also, while we're doing that, what can be retired? So do we need all of this, and are we using it all? If not, maybe we just retire a few things. And that goes for applications as well. So you start making these temporary assumptions, and then you start challenging them. And this will help you to iterate on what you end up doing as you move into the cloud. And so getting buy-in from your actual upper management to make sure you have the space to do this kind of thing is pretty critical. But you can show them through cost optimization that you'll get by switching from a capital expenditure to an operational expenditure shop. You're going to end up spending way less in the long run, even though it may look like a higher monthly bill, because you're going to have you're only going to be paying for what you're using. So you take that, you decide, are we going to lift and shift our entire environment and just reproduce it? You don't even have to rewrite your apps if you do that. You just connect to the new cloud. Maybe you decide, okay, what's our first workload going to be? Maybe it's just a greenfield app. Maybe you have a new app that you need to create and you move that. Or maybe someone got the buzzword and said, okay, it's time to microservice all the things. And you said, all right, I'm going to do that. And so what you do with that is you say, well, we have this monolith, which we'll talk about monolith versus microservices in just a minute. But with that, maybe you don't need all of the monolith anymore. Maybe what you really need is just part of that. And you can talk about, well, instead of worrying about building out a microservices architecture, maybe we just spin up an Azure function that does that code. So we'll see all that in a minute. But ultimately, the other things to keep in mind are structure. So when you start moving to the cloud, who's going to be responsible for what? And this is a very important thing. It's the same thing with technologies, is people's skills. We will have some skill gaps, and that's going to happen. There's no way to avoid that, but that's going to happen whether we stay on-prem or in the cloud. Either way, as we move and migrate to the future, things change and things get more secure or things get less secure, and we have to adapt to that. But with that, don't force people to do things just because you think it sounds cool. So what I mean by that is, okay, containers, great. We're going to talk about that in a minute. Do we need them? If nobody on your team knows containers, understand there's going to be a learning curve to move to containers. With that, though, might be what you want to do, or maybe make some adoption plans around that. So identify what your gaps are going to be. Figure out ways for your teams to partner. So if you have people that are really strong at databases, don't make them do the networking, unless they like to or have a chance to learn that. But don't force people into places that it's going to cause even bigger problems. Identify where you're at, get the skilling initiatives in place, and make sure that you do that as part of your adoption plan. And then overall, the idea is not only are we taking our people and our applications into the cloud, but we're actually modernizing the entire business and how it operates. So we need to look into what Microsoft has available, and with Cloud Adoption Framework, they talk about the Azure Migrate tools that you can use. You can actually use database migrations, app service migrations. There are tools out there to help you plan what your migration will look like, and that gives you the ability to start thinking about your business goals, not just your application goals, but how can I meet my business needs when it comes to operational expenditures? How can I meet my business goals when it comes to getting the application features out there as quickly as possible so my users have the best possible scenario for working with whatever you're trying to accomplish? So all of that working together, it starts to actually shift your entire business mindset of how you set your goals and determine that this has been successful. Oops, I went too far. And so, of course, there's security. And we, talked a little bit earlier about how security has been kind of something we care about. With Microsoft, Azure and the tools that are available out there, security is going to be a forefront concern, and it won't just be something we don't want to really talk about. So one quote here that I pulled out is by Lawrence J. Peter, as far as I could find. That was the source that was attributed to, but it basically says, if you don't know where you're going, you'll probably end up somewhere else. So think about that for a second. If you just go out there and start saying, we're going to do security, all the things. I'm going to keep going back to all the things, by the way. So if you don't like that, I'm sorry. But ultimately, if we just say that and we don't know why or how or what, then we're just saying that. We're just giving it lip service. So you're going to take an assessment of what Azure has available, what you can do, and Azure has tools like Azure Monitor, which helps you determine what things are going on, Azure Advisor, which helps you to see what resources are potentially out of whack with different compliance initiatives or just security issues in general, and Azure Sentinel. You have a full SIEM solution available to you to be able to implement your security around all of this as well. In addition to that, we're talking about asset protection. So with an on-prem, there's really no guarantee that someone's not taking stuff home with them or potentially putting stuff on a thumb drive. Well, with Microsoft now, with all the different tools that we have available, you can actually do some really, really cool things. Like if you send an email that has a Word document in it and that Word document contains customer sensitive data, it'll immediately get flagged just by setting up a few configuration rules. So those are some cool things we can do as well. The idea being you want to start with a zero trust policy. You want to give people the lowest rights possible, and you want to give them the least amount of privilege that they need in order to do their job. And this is not because we don't trust our people, but this is because in order to make sure that we're as secure as possible, we're going to not let you do things until you absolutely need to. Keeping that in mind allows you to protect your organization, but in the long run, that actually protects your people too, because if they don't have access to something that does get breached, then we know it wasn't them, right? With security operations, again, you're transitioning from security as an afterthought. So I build my app and I put it out there, oh, I better make it secure. Now it's, how do I start with security in mind? And the journey includes security along the way. There's no piece of the puzzle, whether it's building a pipeline or whether it's writing a line of code, that we don't want to have a security mindset. So we'll put scanning tools on our pipelines to make sure that our static code has been analyzed for bugs or for security risks. We'll look at things like the NPM dependencies that we're bringing in to see, have they been compromised at some level? And so along the way, we'll have all that in place. Governance, of course, allows us to bring in specific things that we want to have, such as ISO or SOC or the criminal justice or Department of Defense, or even things like the Russian personal data law. There are hundreds of compliance initiatives that you can do at Azure with a click of a button saying you want to have this on your environment. All of a sudden, if you are out of compliance, you'll start getting the alerts you need in order to get into compliance. And so, yeah, and then finally, the innovation security. It means you're not just doing reactive and proactive security, but you're also doing continuous security along the way. So again, that's going to be in our pipelines. Two tools I wanted to call out quickly are the Cloud Journey Tracker and the Cloud Adoption Plan Generator. And I just went out there and filled out their survey, really kind of funny, just to see what would happen, to see what my rating would be. And I got a moderate rating, which isn't bad, but you can go out there and there's a number of questions. It does take a long time, maybe 15 to 30 minutes to fill it out if you're going to actually read through all the questions accurately. It will tell you where you're at and give you a good idea of where you can improve. For example, here, I have some issues with managing and organizing my cloud adoption journey. So somebody needs to get on that. But I did pretty good at governance. So yay me. Anyway. All right. So that's the cloud adoption. Let's talk about well-architected framework quickly. So again, there are going to be some pillars within this that we're going to use. And this is going to home in more on one specific architecture for our application. Now, we might repeat that across applications once we have it in place. But this is versus the wide net we casted with the cloud adoption framework. We're now looking at the more narrow focus of, this is my singular application. And so we have 5 pillars of reliability, security, cost optimization, operational excellence, and performance efficiency. And so ultimately, that's just keeping things in mind here. Let's bring this diagram in. And you see in the middle are those 5 pillars: the reliability, cost optimization, OpEx, and performance, efficiency, and security. Around the outside are the pieces of the puzzle that help hold that in place. So you get this kind of this almost like a Settlers of Catan board going on, right? If anybody's familiar with that. But what we're doing here is we're basically building out our infrastructure around one application to say, okay, this is what we want it to do in order so that if it goes down, we have a failover. If we're needing to scale, we're optimizing only when we scale. So we scale out only when we need to and bring it back in when we don't. So our cost is kept to a minimum. Operational is going to be, what is the sweet spot for us to give VMs a certain amount of compute or throughput on a network, or maybe which version of the app service do we really need to have the right amount of compute each month. Those are going to be your operational excellence to make sure that people are getting the best experience along with their performance that you can get through that. And finally, of course, security. Security is going to, again, be something that we take into account along the way. You see some tools around the outside, the Azure Advisor, different documentation, again, partners like Opsgility, support and service offers that are available. You have reference architectures, design principles, all of that stuff is available out at the Microsoft ecosystem and through people who know where to find it for you. So if you have questions about, what's the design patterns around the well-architected framework, or whatever your question might be, would love to have a chance to talk with you in more detail about why you're looking for that kind of information and help you find it. So reliability, again, this is just going to be, things are going to work when they need to work. And if they go down, we have steps and things in place in order to make sure that they come back up. So we call this HADR, or high availability and disaster recovery. When we move our apps into the Azure platform, we get a guaranteed high availability, usually around 4 nines, which is 99.99. And we can do a little extra configuration if we want to get to 5 nines, which is kind of the sweetest spot to be in for a real world application. So with that, we also get the ability to meet the commitments that we make to our customers on that SLA. So, okay, we're only going to be down 8 minutes this month at the most, and that's only if things go horribly wrong. So you can count on us to be there for you. We will architect our resiliency into the application framework as we go. That way we make sure that our workloads are available at all times and can recover for any failure. And then we can use scaling in and scaling out to handle throughput, making sure that we don't have issues with servers getting overloaded, or just downtime from some sort of other issue that might be happening. Like maybe we're running a sale the day after Thanksgiving, and all of a sudden, we've got an overloaded web server, or we went on the Today Show, and we became famous overnight, and suddenly everybody wants to see our website for whatever reason. Well, we can scale out at will with rules, and we don't even have to be available to. If we put the rules in place, the cloud will do it for us, and we don't have to worry about getting a call at 3 in the morning because somebody's hammering our website. But the other thing is with security around that, there's also tools to prevent things like denial of service. So we just saw major denial of service issues this last couple of weeks. If you tried to use Facebook, you had a bad day one day. Well, Facebook had a really bad day. That was a DNS thing. Okay, maybe not denial of service. They maybe just messed something up. I'm not sure what happened there. But we just saw another thing that Microsoft was just touting, that ultimately with the tools that are built in, the Azure Denial of Service, which comes with the Azure Security Defender, which you can upgrade to on your subscription. It costs a little bit per resource, but it's totally worth it when you have a full real world workload. They were able to handle something like 10 terabits of denial of service attack to prevent Microsoft from going down, which is really awesome. So you can have that kind of reliability in your platforms as well. Along with the security, you have the built-in Azure role-based access control to do identity and access. You have threat monitoring, governance, all that stuff can be built in through Azure Sentinel, Azure Monitor. You can use Azure policies, initiatives, and blueprints to make sure your governance is applied. And you have other information protection scenarios like data protection from corruption. You have automatic encryption of data at rest for your databases, and even information theft can be protected. Again, like when people try to plug a thumb drive into your machine, you can have policies in place that prevent them from being able to download anything to it. And of course, we're all concerned about cost. So as we build out this architected framework for our application, we need to make sure our cost is optimized. And so we will see as we build out these scenarios that we might have to make some concessions for cost in order to get more performance. But if we are able to go to a lower tier, we might get a better cost optimization. The cool thing is that this is consumption based. This is going to be based on our use. So we're not paying $500,000 for a server that gets used 1 day a week. We have the ability to scale for that 1 day at Azure and then scale back down. So our applications can respond without having to spend a lot of money up front and just make sure that we had enough in case something happens. And operational excellence. So this is going to go back for the developers and the DevOps team. When we get our applications built, we want to get them out to the cloud, and we want to make sure that we can do it in a reliable and predictable way so that we can rerun that operation if we need to. And the final piece of that is flip it back. If something goes wrong, we need to go back to the state that was good as quickly as possible. So our idea of building this architected framework around our application also includes automating things that when it's possible, ultimately then helping us to get to a place where we have a decreased cycle time from idea to production as quickly as possible. So we aren't spending months writing code or having long running branches that never get closed or whatever it might be. And again, all of our deployments, we know will go out to the web in a reliable way and go to the right place with the right permissions and settings. Our performance efficiency, again, goes back to just being able to quickly respond when things happen. So scaling in, out, or up and down. And just to quickly in and out means adding more instances or bringing instances back. Up and down means more compute power, more memory, whatever it might be on a single instance. Capacity is just our ability to handle the actual throughput to us. So as our CPU pegs, we spin up another version or whatever, and that gives us a little more capacity to handle that extra throughput. And then we give our customers a better responsiveness on their pages, and the latency goes down because we have the ability to have more throughput. And as we move to the cloud, once again, we're going to containerize all the things because now we're talking about a modern application and the platform scenario we're looking at. As you start addressing your larger, more sophisticated forms of moving into the cloud and your cloud adoption plan, everything's going to become more complex. There's just no way to say it anyway better. You're going to encounter scenarios, and as you move more things could possibly go wrong or could have more issues. So we have been seeing the shift as developers. I believe you've probably even seen this too, into this containerized, orchestrated containers scenario where now we're using things like Docker and Kubernetes. And those are probably going to be the shift for a lot of development in the future. And I think as we've seen more of the open source adoption that Microsoft did a few years ago, spinning into production now of the way that things are going, the more of the IoT world where we have a lot of kind of generally Linux type of commands and scenarios that we've been getting more used to, we're all starting to kind of combine our skill sets across these platforms now. And it's been really cool to see all this happening. And so, we could also have managed services, application services. We can even use our containers in those application services. We can also do our traditional architectures. So please don't think you have to containerize all the things. I do see that trend happening, but it doesn't mean you have to. If your shop is so used to doing .NET or Java or whatever you've been doing in the traditional build out my web server, put my code on the web server, then look into things like app services. You don't have to move to containers just because it seems cool. With your application platforms here, that does give you those options. So here I just did the icons for the Azure App Service and the Azure Container Instances and Azure Kubernetes Services. So those are going to be kind of our three main deployment platforms that you might encounter as a developer. In container world, you're going to maybe use container instances as your kind of your base landing zone. You can also use Azure App Services that host containers. And of course, Kubernetes is going to be the mecca, so to speak, of where we want to go with our journey, right? We need to get there. Everybody thinks that and knows it. They don't really know how to tell you why, but that's the truth. We got to get there. So Kubernetes is an orchestration platform. We'll talk in a little more detail in just a minute, but ultimately it's kind of where we want to go in a real world production scenario as we build out microservice type of orchestrations are necessary. And of course, with Azure, you get security on top of all of this. So you don't have to worry about, if I deploy to the app service, is it going to be secure? Yeah, you actually get built-in HTTPS and you can enable it so that you don't do anything but HTTPS. So really cool stuff going on. So those platform offerings give us the ability to also then start talking about how do we make our deployments repeatable and very easy to do. And that becomes our conversation as part of our development cycle. And we have now made it so that I don't have to care if IIS is installed on the VM. It doesn't need to be there anymore because I'm just deploying to the app service and Microsoft is taking care of all of that. The platform offerings also take care of things like, well, not only handling the underlying operating system, but also updating and patching that hardware and that software to the point where I don't even see downtime. Maybe once or twice I might experience a little bit, but generally I don't even know when they're putting Windows updates on their VMs that host the app services, because that's done behind the scenes and I don't have to care about it. They also take care of my backups for me, which is even cooler. And then, with the push of a button, I can fail over to another region if I need to. If for some reason disaster happens on the, East US or West US region, I can just fail over to the other one because I've got them paired in a way that I can do that. So we get a lot more resiliency than we had in our one data center that just happened to be outside of Chicago somewhere. And when power went out for Chicago, we were out of luck or whatever it might have been. So we're good to go now. The other thing here that's important is, of course, we actually have more tools available to us as well that are easily managed to keep secrets out of the hands of the wrong people and our developers. So as a developer, I can run everything I need to run locally to test it. And when I go to the cloud, if I could create a test database to test against, great. But for production, there's absolutely no reason, unless, depending on your organization size, but for the most part, you could have someone else who's responsible for the production password. You put that into a key vault, your developers never even see it. There's no possibility that they even could access that secret. It's not put into any of the logs, and you're good to go. You also have certificate management and encryption key management handled at the key vault level. You put the right policies in place and you block the wrong people from getting to it. So your traditional first step might be, okay, let's just take what we have on-prem and let's recreate that architecture in the cloud and put our application on it, and you don't have to do any more rewrite. And that's perfectly acceptable as a first step. In fact, that might even be part of your cloud adoption journey, is to first just lift and shift and then apply the changes to your pointing to the database at Azure versus the database on-prem. You then start learning about, okay, well, this is great, but what if I start using app services? So you start moving into this platform to replace those typical environments. You get then the high availability, the security baked in versus having to configure that yourself. When you do the lift and shift, you are going to have to do some special configurations on your own to make sure you still get the high availability and disaster recovery. So it won't be there by default. And so you have to kind of understand that. But with the platforms, you get it for free. Well, not for free, but for free as far as effort. And so with that, you also get the tools that come along with anything at Azure: monitoring, testing, instant metrics on all of your services, all that's available. And as you do adopt containers, you have containers creating a similar layer of abstraction between the application and the underlying operating system. So where we, excuse me, where we saw the platforms giving us a layer of abstraction between where we're deploying and the actual underlying hardware, the containers themselves take that a step further and separate us from the operating system completely. So we no longer have to worry about where this is deployed, as long as the host can host a container runtime and we can put our container in that runtime, it will work. Our containers will build themselves. Now, this gives us some really great security benefits, because it also gives us the ability to run things side by side that sometimes might not have played nice. For example, I might be able to run a .NET 4.8 framework and a .NET Core 6 application side by side, because I have no concern about those two things and their different .NET frameworks interacting with each other since they're containerized. They're also immutable, which means that once it's deployed, it can't be changed. That can actually be a drawback in some scenarios where it means you have to basically destroy and recreate a container if something changes, but it can also be a good thing because that means there's no configuration drift. Once it's out there, it's out there. And so you use these pre-built images stored in a repository, much like you do with your code in Git. You put your images into a repository, you deploy them out there, and you're able to quickly and easily spin these up. And because they're containerized, you don't have to wait for an entire VM to boot. You just have to wait for a new container to spin up, which is generally seconds versus minutes. So it can be much more beneficial. Another thing is you can have one running .NET and one running Java side by side. And that's pretty cool. And we don't have to worry about Java not working and .NET not working because the other one's there. And on top of that, then you get the container orchestration. This is where we're talking about Kubernetes. We get the ability to start moving into handling the lifecycle. So if containers start dying or don't have good health, Kubernetes is going to take care of that for us. But the other benefit is going to be scaling in and scaling out quickly. So whereas with a smaller instance, we might have to be responsible for scaling in and scaling out, or at least maybe have some metrics and rules. With Kubernetes, you're going to see you could set some thresholds, and you do this declaratively, where you basically in YAML can go in and say, I want to have this many pods, and it basically will just make sure you have that in place. And so you don't actually have to do all the commands yourself. You just declare it and it goes out and happens, which gives you the ability to have your entire ecosystem managed seamlessly without having to be kind of hovering over that. So I just realized I've been talking for a little bit. I was wondering, do we have any more questions? I haven't, I forgot to check, so.
Yeah, no worries, we do here. We have one learner ask, how can we make the shift from traditional to containerized development, and what's the path to that? I know you spoke about it in a little bit more depth, but I don't know if you could just refresh a quick summary for them.
Yeah, sure. Wow. So how do I move from from traditional to containers? Well, there's good news and there's bad news. So just like anything, you're going to have a little bit of a learning curve. So if you think back to when you first learned Git, maybe you were used to using Subversion or TFS in a centralized way, and you had kind of this learning shift. There's a little bit of a learning shift like that with Docker. You have to learn a few commands. You have to learn a few things to do that. But the really good news is that Microsoft has all these things in place already that allow you to quickly get images for their .NET frameworks and such. You start that as your base layer, and you're able to basically take your existing application, and as long as you start kind of understanding those commands, you don't have to make any changes to your code at all. So the shift is going to be more of just the what's the word I'm looking for? The shift is going to be more of just a kind of an ecosystem of your own framework in your own mind of, instead of running .NET build, .NET publish, and then having this architecture or this archived package of deployed artifacts that I'm going to either FTP to a server, right click and publish, or put in a pipeline, whatever it might be. Now, I just say, this is how it builds within the container Docker file itself, and then that's taken care of. There is a little bit, again, learning about the virtualization of the paths inside there, but your app will just work once you get it set up correctly. So it's not, you don't have to do anything special to your code. So the shift is early. If you decide to do this, you end up get that learning curve done, and as soon as you start getting that done, then all of a sudden you have the ability to do both. You can still stick with traditional, and you can start containerizing. And yeah, that's a great question, because again, don't force your team to learn something just because it's a cool word. Make sure there's reasons, and once you understand those reasons and can justify them with your business goals and your cost goals and different things, then definitely get the skills use your skills initiatives to handle that. Great question.
And then one last one here is,
sure.
Which platform should I use, and how do I choose between ADO, GitHub, and GitLab?
Oh, okay. So that one, yeah, we're going to talk about pipelines in a little bit, but with that, when you're doing your pipelines, yeah. So which one do you currently use? That would be my first question, because if you're currently using ADO, don't move to GitHub just because you need to move to GitHub. You don't have to. Or if you're currently using GitHub, don't move to ADO just because. You have reasons, a business purpose behind it. So ADO is a really cool place for, ADO is Azure DevOps. It's a really cool place for learning YAML quickly. And also it has boards. Well, GitHub has boards too, and I'm sure GitLab and Bitbucket have those also. So if you've already got your code out there, migrating it might be useful, or might not be. So you would want to make an assessment, because all of them are going to be able to do what you need to do. And so again, don't force your team to learn a new tech stack just because. And ADO itself also has the ability to leverage GitHub repos. So that's kind of cool too. So if you do want to use ADO for your board management and GitHub for your code management, you can actually do a hybrid thing like that too. Yeah, that's an interesting question. You definitely want to make sure that you follow through with what the business goals are behind the decisions, and make the right decision for your team, not just because something sounds cool. Awesome. All right, let's talk about microservices quickly. And so here we see with the microservices, the ability to move quickly and change our architecture. So we have monolithic applications now. We wanted monolithic. We even have monolithic databases. Those have created problems for us along the way. Microservices comes in and says, okay, let's take some of the functionality and split it into its own unit of work. And we keep these small and independent and versioned so that we can move quickly. So what we might do is start with our conglomerate and then start piecing that out. And so we'll see that here, where we're looking at using App Service Fabric at Azure. And Service Fabric is just a specific resource at Azure designed to help us make a move into microservices. So we can take approaches to start out by taking our monolith, move it into a container, and then take that container and start adding sidecar microservices alongside of that. And what I mean by that is quickly take one piece of the functionality that you're looking to make into a microservice and implement that in its own container. And now you still have the monolith, but you also have your single unit of work, and you start doing that. Now just be careful as you start doing that, because now that means you have two pieces of code that are doing the same thing, and which one's using what and who's using who. So you have to be very careful in your planning on this. You end up breaking up all your pieces into microservices, and at the end of the day, you end up innovating around that and transforming that entire monolith into a microservice architecture. The other thing is, and this is the paradigm shift, there are two major concerns I would always offer to you if you're going to start moving into microservices. And as you start building these out, just remember that although microservices sounds cool and we do get really quick cycle times, we are taking some risks because we have now maybe made our application much more complex than it needed to be. We're developers. We like to over-engineer everything. If you would give us 47 years to write a line of code that we could make it look perfect, we'd probably take it. So we need to be careful that we don't over complexize, or whatever the word might be for this, make it too complex. We also need to think about our data. So in the past, all of our data from one application has been in one database, or maybe, a load balance database scenario in the worst case scenario. But what if we start doing microservices? Should microservices all be using a monolithic database? I don't think so. Well, that changes the paradigm right there. Now all of a sudden we have microservices that need to have their own data. And how does that play nicely with other microservices that are doing the same thing in a database? And our relational data structures and thoughts that we've had for all these years start to kind of break down a little bit. They're still there. We just have to figure out how to work with them. And then state. State is a big deal. Now, not only do I have this interconnected web of microservices where I used to have one deployment, I've got 10, 20 deployments. I also have state to manage. Like, what do I do if I need to live past the first run of this and get the data again? And I went from one microservice container to another and back to this one and over here and down here, and all of a sudden I don't have my data anymore. Where did it go? So that becomes complex. And network congestion, now I've added all this different network traffic. I'm probably using some sort of servicing, service bus type of messaging, eventing, something to help track where I'm at and orchestrate all of that. And then finally, the lack of governance could be a big deal too, because now I've put things into a container, it might be able to skip over some of the concerns, especially if that container is responsible for its own data and it's not getting evaluated for whatever reason. So you have to be very careful. And then in serverless development. So this is another one of the big words. I like to take the quote from Scott Hanselman, which I used to credit to Scott Hanselman. I'm not sure if it was Scott or Jeff that said this first, or maybe both. But anyway, serverless doesn't mean there are no servers. It means let's think about servers less. Okay. The cool thing is it does mean we can quickly move code. And so instead of using containers, you might decide, well, maybe I just want to write code in an Azure function. That's awesome. You can do that. And then you don't have to worry about containers if you don't know containers, but you can still build a microservice architecture using Azure functions. You can start doing things with that. You can do burstable and consumption based, so you're only paying for what you use. You can use API management on top of it to give a facade. You can use your service bus messaging, your event grid to orchestrate things. You can even use logic apps, and logic apps give us the ability to orchestrate a workflow as well. This is also really handy. Serverless components are available for us for big data, for IoT, for stream processing. There's literally all kinds of different uses that we have out there at Azure for serverless types of development. We're no longer using a monolith to do everything with one database. We now have all these different functional components that work together to create a scenario and a solution. So functions itself, again, we do generally a consumption-based plan, but you have the ability to do an app service to back it, so it can always be on and have more throughput. But you can even do an app service environment where you have isolation if you really needed to. Additionally, you could bring it on-prem if you wanted. I didn't put that on the slide, but it's important to note. If you decide you want to try to do some hybrid scenario, you can bring, your on-prem version of Azure Stack or whatever into your organization and run Azure functions. There are two types, traditional and durable. Traditional was what we used up until a few years ago. They always ran less than 5 minutes. If it went over 5 minutes, it killed it automatically. Now there's durable. So remember I said about state function a little bit, managing state. Durable functions in Azure Functions actually have state management, which is an interesting thing because they weren't designed originally to have state, and now they do. So it's another learning curve, but it does give you a little bit better state management. All functions, and we'll see this with logic apps as well, have triggers. Something has to tell it to run. And so that could be a schedule, it could be an event, it could be someone dropped a file in storage and we need to run something. It could, that's what you see here. You got a file being dropped in storage, triggers a function, processes it, and then ultimately sends it off to Power BI. Azure functions have bindings on the front and the back side. So whether or not it's an entry point or an exit point, we use the bindings. If we don't want to write the plumbing code, we can actually just say, I want to connect to Cosmos DB through the bindings, whether it's an input binding or an output binding. The logic apps give us the ability to orchestrate the workflow, which gives us triggers, again, to get the entry, but then we have things called connectors. There's over 200 connectors, which allow us to connect to things like Twitter, Twilio, SendGrid, whatever it might be, Azure Cosmos. We can respond to events that happen, such as a hashtag tweet and kick off an Azure Logic app, or again, dropping a file in storage. The connectors then are charged each time they're executed, and the actions are charged each time they execute. But you can build workflow plans with the conditions and loops that you need in order to have different paths. You can do parallel branching. So it's definitely great. And if you've ever worked with Power BI, I believe there's a thing called Flow that's a very similar tool. Event Grid is kind of the behind the scenes type of thing that happens with Azure to alert something that something happens. Pub sub, so you can then filter by the subject that happens on the event and use that to respond to it. So in this little scenario here, you see an event grid fired after something was captured from Event Hub. It was then triggering the Azure function, which then wrote to our SQL data warehouse. So an ETL or extract, transform, load type of scenario here. It's deeply integrated with all the Azure services, so you can respond to the events as you need to. So you want to look into that in more detail, probably if you're going to be working with your actual serverless development. And then finally, we have build automation. So as a developer, the last piece of the puzzle to modernize our app is to make sure we can do our deployments in an automated manner and to be able to get them out there as quickly as possible. So CI and CD. And so what is CD? Is it delivery or deployment? And are they the same thing? And what is CI versus CD? Well, continuous integration means that when I check in my code, it's continuously evaluated. So whether that's creating a pull request against the main branch, I then am able to get the evaluation run. That's continuous integration and potentially the build of the artifact from that. Ultimately getting that build completed, and I know that my code works and it's been scanned and it's not going to cause problems. Continuous delivery then is kind of the middle piece of that. It's not deploying to the actual environment. It might be delivering it to container registry or delivering it to Azure artifacts. or just even an output folder of some sort where I have an artifact that was produced, whether it's an image or a zip file or whatever it might be, delivered somewhere at the end of the pipeline. And then deployment is the actual act of releasing it. So getting CI and what we'll call CD in place, overall, we're going to say is getting the build run, making sure your code is scanned, getting your artifact published, getting it out to your actual environment, whether that's app service or Kubernetes or Azure Container Registry or whatever your target is. And so here we see just kind of an example pipeline that I built a while ago for a simple Azure web app. And ultimately this is triggering on, this is a pipeline in GitHub. So it's a GitHub action versus an ADO pipeline, which you might look different. So if you're used to those, this might look just a tad bit different, but it's very similar. This is triggering on a push to, unfortunately, the master branch. Again, this was built a while ago, and ultimately it's building and doing some steps. And so you use your YAML to write your code and get it out there. You can use variables and secrets within your code. You can use the different jobs to do things on your code. Steps along the way give you the chance to actually execute things, and all of these run on an agent. And the agent is just the machine that's executing the builds and the deployments, or the tasks, the actions. This is just a couple looks at Sonar Cloud. Again, this is a GitHub, but there's the same things available at Azure DevOps, or probably for sure Bitbucket and GitLab. I'm sure they have similar tools. This is when we start talking about rugged DevOps, excuse me. We're looking to build out a pipeline that's not only just getting our CI and CD done, but it's ensuring our quality along the way, our repeatability, and our lack of issues. And another tool is the OWASP Zap tool that you might look into. This is not only going to be your scan, with Sonar Cloud or whatever, your static analysis. It says these are your bugs, these are some smells in your code. The OWASP Zap will actually run penetration. And again, what you're going to want to do here is just take a scenario and determine what's the best path. You'll probably do a lightweight scan during the live build and push because you don't want to slow things down. You may actually run a nightly scan to do that full scan here. So you see that baseline scan, maybe an API scan, but then the full scan you probably run on a different pipeline to do things at night. So the last thing here, just wrapping it up, we talked about the traditional architectures, the move with the cloud adoption, the well-architected framework. We talked about some of the applications of the cloud apps, microservices, and serverless development, kind of the trends of the future, and just automating our builds.
Thank you everyone for joining us today. If you have any questions at all, please feel free to contact us at sales@opsgility.com, and we will get you scheduled with a strategic account team. And again, we're here to help you build your cloud strategy. We're here to assist with creating applications and all of your migration needs. We can help you get from A to Z with as much or as little support as you need, whether it's just one class or if you need us to complete the migration for you. So in the meantime, please feel free to attend our next webinar and check us out at the link below. Thank you so much.
And assuming then there's no more questions, or I don't see any, so we'll go ahead and wrap it up for today. But thanks again for giving us your time, and we'll look forward to hearing from you in the future. Thanks.